Pull request 326545 refactors how VS Code's agent system seeds subagent opening messages. Instead of the orchestrator parsing provider-specific JSON, each agent provider now explicitly supplies the delegated instruction directly on a signal field. We're pursuing one major goal: making the subagent opening request flow completely provider-agnostic. That means removing provider-specific JSON parsing from the orchestrator and having Claude, Codex, and Copilot each supply the task prompt directly. We're also respecting a key constraint. The empty string fallback for missing prompts stays in place, so existing callers keep working. Previously, the shared orchestrator extracted subagent task prompts by parsing provider-specific tool input JSON structures. That coupled the provider-agnostic orchestrator to Claude's schema, Codex's schema, Copilot's schema, a fragile pattern. The commit history shows the forcing function. With every emitter covered, that tool input recovery became redundant. By shifting prompt extraction to the provider layer, we're letting each agent surface the prompt at the moment it has the most context. Let's look at the new signal interface. We've added an optional task prompt field to the subagent started signal. The comment documents that each provider populates this at emit time from its native source, and the orchestrator uses it to seed the subagent peer chat's opening request. It's distinct from the shorter task description, which is just a tab title label. Here's the orchestrator refactor. The handle subagent started method now accepts task prompt as a parameter and seeds the opening message directly from it. The old path that recovered the prompt by calling task prompt from tool input is gone. We're reading the prompt straight from the signal. The empty string fallback stays, so if task prompt is undefined, the message defaults to an empty string. The task prompt from tool input method, all 28 lines of provider-specific JSON parsing, is deleted, no longer needed. Every provider now supplies the prompt directly on the signal, so the orchestrator never has to recover it from tool inputs. All three providers now implement the pattern. Claude extracts the prompt from its tool use block input and records it in the spawn registry, then sets task prompt on the signal. Codex does the same with its item.prompt field, including an explicit string type check and length validation. Copilot grabs the prompt from tracked.parameters and type checks it before setting the signal field. Every provider follows the same contract. The test fixtures reflect the new pattern. Instead of embedding the prompt inside tool input as stringified JSON, tests now pass task prompt directly on the signal. The nested subagent test verifies that prompts flow correctly through 3 levels of subagents, with each child receiving its prompt via the signal rather than from a tool input fallback. After this PR lands, subagent opening request seeding is fully provider agnostic. The orchestrator never touches provider-specific JSON. Each agent extracts the prompt from its own native representation and supplies it on the signal. The subagent's opening message is seeded directly from that task prompt field, and the empty string fallback keeps existing callers working. The agent looked at 7 areas and found them all clean. Type safety is enforced. All 3 providers check that the prompt is a string before assigning it. Backward compatibility is preserved with the undefined to empty string fallback. The nested subagent test verifies correct prompt flow through 3 levels. Claude's ID impotency guards are respected. And since task prompt is optional on the signal interface, existing callers not passing it remain valid. That's pull request 326545. A focused refactor that decouples the orchestrator from provider-specific JSON parsing by having each agent provider supplied the subagent task prompt directly on a signal field. The signal interface is extended, the orchestrator is simplified, and the tests verify the new flow works through 3 levels of nesting: clean, provider agnostic, and backward compatible.